All right, so welcome to week 3 already. Crazy. Um, to, Today we're going to introduce a new type of data, a new type of container. Okay, so far we've talked about strings, integers. Remember, integers are numbers with no decimal, floats, which are numbers with a decimal. And you'll see why it's important to have two different types of number. It seems maybe like it's redundant, or why would we need a different type of data for a number with a decimal versus without? Um, that will become more clear, the usefulness of that later in the class. And then finally, we have Boolean data types, which always evaluate to either true or false. We haven't really used Boolean much yet, but we will. So today we are going to add another data type. And the interesting thing about this is that it's new, but it's not new. And what I mean by that is we're going to start talking about something called collections. A collection actually has a few different specific subtypes. And today we're going to talk about one specific subtype of a collection called a list. As the name implies, a collection is a variable type that can hold more than one thing, just like your Lego collection or whatever. It's more than one. It's not a collection if it's just one thing, it's just a thing. Now we're going to be talking about collections. Specifically today, I'm going to introduce you to a data type called lists. And lists are a type of collection that can hold any type of data, okay? It's just going to hold more than one thing in it. Now you can see this AR pets. I call it AR pets. It might be called LI pets because lists are also sometimes called arrays. You can use whichever makes more sense to you. Officially speaking, Python calls them lists. Every other programming language out in the world would refer to this as an array. So those things are interchangeable, those names. So when we name a list or an array type variable, I'm usually going to precede it with li for list or ar for array. I sometimes slip back and forth between the two because I don't really think of them as any different. What you'll see here is in Python, a list always looks a certain way. So this AR pets equals, you can see it's got dog, cat, fish, and bird in it. Those are all strings. We can tell that they're strings because they have quotation marks around them. If they didn't have quotation marks, what we would assume is that those are probably variable names. Okay, so if you see characters that aren't numeric and they're not true or false and they don't have quotation marks around them, a lot of times we just assume those are variable names, even if they don't look like variable names, because a string always has quotation marks around it. And you can see the structural elements of this list or array. It's got square brackets. Now notice those are square brackets. They're not curly braces. They're not parentheses. All of those do different things. In this case, they are the square brackets, and each item in that list is separated by a comma from the other items. Now, how many items are in this list? 4, right? Dog, cat, fish, and bird. The things about arrays that we can count on when we're programming with arrays or lists is number one, they are ordered, which means every time I use this list, the items in that list are always going to be in that order. And that's useful because we can count on the fact that dog is always going to come first. So if I have an array or a list, I can count on that order being the same each time, and then I can use it in that specific way. It's not going to randomly change. Now I can, and I'm going to show you how, but I can change the order of the things in this list manually. But unless I explicitly change the order, that order will stay the same. That's what we mean by ordered. Indexed refers to the fact that each item in this list is assigned an index number. It's an integer that refers to the position of that item in the list. Indexes, anytime you see the word index or think of the word index or hear the word index associated with programming, your mind should always go straight to one thing. Indexes always start with 0. They never start with 1. So item number 1 in this list is what? Cat. Item at index number 1 is cat. Dog is index 0. So we start with 0, 1, 2, 3. There are 4 items in this list, but the last item in the list is number 3, is index number 3. So we can use those index numbers to refer to specific items in that list. If we want to read from that item, if we want to change that item, even remove that item. So we use that index all the time. That's how we primarily interact with a list. Mutable, just like Teenage Mutant Ninja Turtles, mutable implies that the items can be changed. There are collection types where the items cannot be changed. We're going to get to those later on down the road. In this case, you can change any of those items. So I could take lizard and change it out for fish if I wanted to. Or I could add another item, or I could remove an item, or I could sort those items in alphabetical order if I wanted to. Also, any object, any type of data can be held in here. And it doesn't have to be the same. I could say dog 2375.5 false if I wanted to. I could have one of each type of data in this list. Now that would be an interesting use of the word of the construct of a list, because a lot of times what we have are multiple items of the same type in a list. Not always though, and it doesn't have to be.